This question comes from Marcus, who asks, if every nuclear weapon on Earth was launched at the same time, at the same moment, what would actually happen? Walk me through it. Great question, Marcus. Let's count down. The arsenal. Before we start the clock, let's establish what we're working with. Right now, the world has approximately 12,500 nuclear warheads. The United States and Russia together own about 90% of them. The remaining 10% are split between China, France, the UK, Pakistan, India, Israel, and North Korea. The total explosive yield of all these weapons, if detonated simultaneously, is roughly 6,600 megatons. That's 6.6 billion tons of TNT equivalent. For comparison, the bomb dropped on Hiroshima was 15 kilotons. We are talking about a force 440,000 times greater than that, all at once. Let's press the button. The first few seconds. The moment every warhead detonates simultaneously, approximately 4,500 individual fireballs bloom across the planet. Each fireball reaches a temperature of roughly 100 million degrees Celsius at its core, hotter than the surface of the sun. Within milliseconds, a shockwave expands outward at supersonic speed. The air itself becomes a weapon. Buildings don't just collapse, they are erased. Concrete turns to powder. Steel bends like paper. But here's the thing most people don't consider. Not all weapons detonate on the ground. Many are airburst detonations, designed to explode above cities to maximize the shockwave's footprint. A single 1 megaton airburst over a city the size of New York doesn't just destroy Manhattan. The overpressure zone extends for dozens of kilometers in every direction. Every glass window within 30 kilometers shatters simultaneously. Every eardrum exposed to open-air ruptures instantly. Within the first 60 seconds, every major city on Earth that was targeted, and most were, is simply gone. The first hour. This is where physics takes over completely from politics. Each nuclear detonation throws an enormous column of superheated air and debris upward. This column punches through the troposphere and begins depositing soot, ash, and vaporized material directly into the stratosphere. The layer of atmosphere that sits above weather, above clouds, above rain. Material that reaches the stratosphere doesn't wash out in a week. It stays there for months, sometimes years. With 4,500 simultaneous detonations, the amount of material injected into the stratosphere is catastrophic. Estimates from climate scientists suggest that a large-scale nuclear exchange could inject between 150 million and 300 million tons of black carbon soot into the upper atmosphere. This number matters more than the explosions themselves. Within hours, a dark veil begins spreading across the planet. It follows air currents. It doesn't respect borders. It doesn't stop at oceans. The fires are also still burning. Every city that was hit is now a single enormous firestorm. Fire tornadoes pulling debris and oxygen inward, generating their own weather systems. These firestorms add even more soot to the stratosphere. The feedback loop has already begun. The first week by day 3, satellite images, if any satellites survived the electromagnetic pulses, would show something deeply wrong with the planet. The stratospheric soot layer is now global. Sunlight is being reflected and absorbed before it reaches the surface. Average surface temperatures begin dropping. Not dramatically at first, a degree here, 2 degrees there, but the trajectory is unmistakably downward. Agriculture immediately begins failing, not because of the cold yet, but because photosynthesis requires sunlight. Crops that were growing simply stop. The signal from the sun that tells plants to convert carbon dioxide into food has been cut off. Farmers have no idea why their fields look wrong. Most farmers, of course, are no longer alive. The electromagnetic pulse from the detonations has destroyed most unshielded electronics across vast regions. Power grids are down across North America, Europe, Russia, and large parts of Asia. The cascading failures we discussed in a previous episode, fuel running out, nuclear plants shutting down, backup systems failing, are all happening simultaneously, everywhere, at once. The first month. This is when scientists call it nuclear winter has begun. Surface temperatures in the northern hemisphere, that where most of the detonations occurred, dropped by an average of 20 to 30 degrees Celsius. In some continental interior regions, the drop is closer to 40 degrees. In July, Moscow sees temperatures below freezing. In August, the American Midwest experiences frost. Growing seasons don't just shorten, they disappear entirely. The southern hemisphere fares somewhat better. Australia, New Zealand, parts of South America, and sub-Saharan Africa receive less direct fallout and fewer direct strikes. But the atmospheric cooling is global. No hemisphere escapes. Average global temperatures drop to levels not seen since the last ice age, roughly 20,000 years ago. Food stocks, whatever wasn't destroyed or irradiated, begin running out. Modern civilization carries roughly 90 days of food reserves at any given time. By week 6, those reserves are gone in the surviving regions, and new food cannot be grown. The greatest killer of nuclear war turns out not to be the bombs. It's the famine. The next few years. Here's the number that matters most. Scientists estimate that a full-scale nuclear exchange could kill between 5 billion and 6 billion people. Not from the blast, but from starvation caused by agricultural collapse during nuclear winter. The soot layer in the stratosphere persists. Unlike volcanic eruptions, which inject sulfur dioxide that washes out in 1 to 2 years, black carbon soot from nuclear firestorms stays in the upper atmosphere far longer. Some models suggest meaningful cooling for 5 to 10 years. Growing seasons remain stunted. Rainfall patterns shift dramatically. Monsoon systems, which feed billions of people in South and Southeast Asia, collapse or relocate entirely. Ozone depletion follows as a secondary effect. The extreme heat of nuclear fireballs converts atmospheric nitrogen into nitrogen oxides, which then chemically destroy the ozone layer. Within months, ultraviolet radiation reaching the surface increases dramatically. Surviving outdoor crops are now also being cooked by UV radiation. The planet's biosphere is under simultaneous assault from cold, dark, radiation, and starvation. Some species will not recover from this.